Hello, my name is Shmilov Yaroslav. I'm the student of the first course of Intermediate Computer Counter-Criminalistics in the NIX system. Our main purpose of our project is to develop main concepts of protection computer against and protection against stored information, also practical implementation of all the methods, easy to use, everyday use without any qualification. Comprehensive protection of computer would always be important, not just for the black hats, although our methods allow to effectively counteract both criminalists and computer technical experts. At the same time, they allow to counteract different criminal elements. That's why this is very important, not for the business structure, for the government, and for the regular users. In our system, criminals could get access to data stored in the computer only. You can get access to the computer loaders and to force user to name password the loader. At the same time, the user should maintain very simple rules, use a reliable password for the loader, extract it from the computer against after switching on. Could be any flash card, hard drive, but best use the USB drive. And also desirable to install a password on the BIOS and make BIOS loading longer, which is going to be better in the cold boot attack. And in case of danger, you need to destroy it as soon as possible and switch off the computer as quickly as possible. We can destroy the key. There's then we can easily change the passwords, but at the same time, it would make little sense because the carrier is protected. We will have plausible deniability with two methods. We'll use the full disk encryption with deletion, tom header. What does it mean? We have a computer and hard drive, we have such information. Statistically, randomly not be possible to differentiate. There's no headers, nothing. And we have USB drive, which is the carrier loader. That's daily method. It's very countable. Less countable, but more reducing method. We are using so-called double bottom container. We have a certain file in the Windows. If we encrypt the file and we mount with one password, they have our personal pictures. If we got loaded from the USB drive from that file, we launch Linux for Linux system. And in case if they ask us to say password, we can always name the first one, and we can even at the same time destroy the data which are stored in second section. This could be applicable as well, and basically it's more or less working fine with decent speed. So what is the structure? This regular flash drive, it has a grab, could be in the file system, like file 32. Also the deluxe section, protected with password. In case we lose that, we lose almost nothing. Also, the system allows us to quickly change the keys. If we lost our carrier, then 3-5 minutes we can change the passwords, and then even if our password is found through the brute force, it'll give nothing. In terms of user point of view, it looks very simple. Beginning they see the screen like to grab, then they enter the password, and then our section of set it today in core, and that's it. And it works with the regular system. How it looks like. We have those DB, it's our hard drive, as you can see from the dump. You cannot see well, but it's so clear that it has no header. But to my right, there's a structure for USB drive, the X2 section, and there's no important information in the loader. The only function is to code the following called boot attack. That's one of the only few really dangerous attacks in our systems that in order to get protected against it we need to put it into hibernation mode. That we do. If we move away from the computer we need to move into hibernation mode. Then in order to get loaded we put in the loader again and get loaded again. So the computer is taken hard drive is extracted, you'll probably not find anything. Even if memory were able to extract the two methods, first with the liquid nitrogen, it is frozen and brought out somewhere and lies that if in 3-5 seconds they manage to grab out the computer, move a memory which is almost not realistic for network laptop. If we're unlucky, there's a chance that they might find our key. We use regular method when we get loaded from the USB drive and dump the memory, hoping that they'll have something there. This method must be blocked if we are using the password for BIOS. By the way, about the tactics of criminalists, including industrial spies, many that use that protection get logs, checks bombs, computer is switched off, then the hard drive is extracted, and with some means you get copy information. So case is useless. So in addition to that system, there's by the way the guideline on how to use that is placed on my GitHub. Also they have samples of the virtual machines where the system has been writing. We can download virtual machines, how it works. So migration to this system in principle is not very difficult. It takes 2-3 hours, including formatting of disk because then there's a hard drive re-recorded with the random data and then copy. Then we have realized kernel space keylogger. Main feature of that is that it can operate in two modes. First, it doesn't ask for super user rights. It works with the X server. In Linux there's a funny feature that any software which works on our server which can get all the events including keyboard. If we use any manager password and launch not very trusted program, software like Skype, any exchange buffer content could go in the wrong place. Now we can use also we use the method of complicated identification through using another mode. That mode we use from dev input event 0. We make a copy out of it, we start reading and leaving that file from our command. And then it complicates the identification of our keylogger using different root key checkers, and with the current version we can find it. And also we are using asymmetrical encryption. Most of keyloggers, like Lockheed's very famous Linux keyloggers, I was nervous that all the data stored in the open type, and we are helping the bad guys to get our passwords. By the way, we can know that the password which we get, it was stored without root right. So therefore we can, if we don't use asymmetrical or any other encryption of our data could easily get to bad guys. And also then we generate private public keys, and then in the future when our key loggers is working, then they first register session key as with the RCA key, public key, and then record to the header of our log file. Then in the future to decrypt log file could be the last one, and only through extracting the respective key from the keylogger memory, or have a private key which can protect it. Also, we have implemented the kernel space version of the keylogger, which works as a module of the core, and it can write files. But fortunately, so far there are some difficulties with adding of RCAP to the core. That's why they're going to have hell. It's the mode first, and implementation is going to be, I hope, somewhere at the beginning of summer. So far, that. Also, we want to add support of sending logs by network, possibly using the iconography means. So that's the example of how it works. Using instant mode, we switch our logger, we enter something, and then using the parser, we get whatever user was pressing. Also, using the keylogger from other space, they can work with the Russian keyboard. If they can write English text, if you have Russian, they would be recorded as the normal way, the way it was written. As you can see, Loajit, we actually using Lua, but for the parser and for the first keylogger generation. So the keylogger code is written and see it's available in my repository and could be distributed through the license. It's all possible to be modified or changed, etc. Basically, using our methods will not strongly impact the capacity of the system. Our method of operations are used with the old machines without big overhead because encryption works much faster than reading or writing at the hard drive. So using the system, we do not see any big difference, but data security strongly increases, of course, using these methods, and of course, we are fully open and using the local protection information system. We almost were not writing our own codes. We were using the existing Linux features which were checked many times by leading experts in information security. We were using just the parts which are written on Bash, except Rooklit we had to patch it up in it as. We are using Bash scripts which could be easily checked and used for our services, and that's it. I'd like to show a couple more screenshots. Unfortunately, I cannot show the virtual machine itself, but take a look at that screenshot. As you can see, that's how the two sections of our USB drive look like. Left is unencrypted. There is no important information. Second one is encrypted. It contains the core itself. The only interesting thing is the parameter root, which is written whereas the rootfs. We may do it non-unique, and that's basically it. The rest is environment block which has nothing, and standard mode which is the same for photographs. And there's a screenshot here. There's a system loaded from the crypt file, which is an infotest section made with media stack. The real situation must be some Windows or Linux there, just that support interface, but NX2 with main file systems as well. And this system is work okay. The only thing we need is to make more larger size of the file container, because the system requires a lot of memory, especially when we use double bottom. And basically that's it. Do you have any questions? In which way you store a password for decoding of a disk? We have Lux department. You've heard about Linux Unified Crypt Setup. User, when they load up the USB drive, enter the password grab using, as far as I know, the crypt disk or crypt something mode. It's more to work with this Lux department, and they open that. So basically, that's the first password for the USB drive. Password for the grab section. It's not store. User remembers that. And also in Internet we have embedded key for the hard drive itself. Thank you. What operation systems you're supporting? All Linuxes is quite easy to migrate to free is that. No serious limitations, everything what grabs do, and decent full disk encryption. In Linux it's Flux, FreeBSD there. Also I don't remember the name, but all NIX systems which are using grab and full disk encryption could be applied. The first scheme and second scheme works for all the systems where ProCrypt is working, except Windows of course, for obvious reasons. So you're using everything in ProCrypt and TroCrypt. We have two realizations. First, encrypt setup, which is full disk encryption without a pattern. In the TrueCrypt, we have dismounting it from the file, which is in a section with the double bottom. We have two concepts. We encrypt everything. There's, I guess, normal daily version, and second, we use only when the full disk encryption is suspicious or prohibited. In fact, it's TrueCrypt is suspicious itself. There was a bad thing happened to it recently. It was closed, yes, but so far that was the only thing which allowed to use this double bottom in the normal version. And it was checked by the expert, and they really found nothing serious, although it was closed, support stopped. They're working on to continue working with the code. As soon as they have something new, I would immediately migrate there, of course. But TrueCrypt so far is the version for very special cases. The main thing we guess would be to use locks. Thank you. Would be possible. They have a connection. If the logger is written, it will be possible that it will not follow the local machine. Yes, that I was saying. We will use some means. We will send it through pictures and hide it like stick hide. We maybe do that through simple sending in the encrypted mode. Could be implemented in the nearest future as soon as the session is finished. Machine is not infected. We are not writing malware. It's just a software which is launched. You can add to Linux through many ways. Whatever you want, you can use. A big advantage that we do not require root rights, just local user rights that we want to monitor. And that's why we can launch it any way we want. Hello, I'd like to ask what algorithm is to encrypt 256 IS hash 256. but user can choose any of the available looks algorithms. There are many of them. I guess blowfish if you need to encrypt quicker and other options as well. So any of the available looks. Linux unified crypt key setup. A lot of that is supported, but I guess the main SD256. When next question, when you go into hibernation mode, Hibernate file is encrypted. It's coded well. The whole hard drive, nothing is left uncoded. If we get out all the data out of hard drive, no statistical methods will be able to prove that they really store data. We just not that doesn't get anything randomly. Coding of Hibernate files, yes, you've managed to do that. Yes, I understand. Because in TrueCrypt normally, Hibernate is not coded when it goes to hibernation. Yeah, that's a big actually problem with main systems like that because when which are used by default with the TrueCrypt or with the Lux software through distributive as the hard drive is coded partially like only home department section loader. It causes a lot of problems indeed. The bad guys can replace files with files and data, but it's not true in our case. We code up everything. Are you protected somehow against attacks with removing memory in direct mode, like through the fireware? Memory keys are an open access or they're protected somewhere. It's quite difficult not to keep keys. There are some processors that support that, but I don't know if somebody is using Apple fireware. They need to make sure that their memory could be removed. But normally, there's no direct removal of memory, and for that we need special cold boot attacks. But if we use Apple again with fireware, we need to be more careful. We watch when we are stepping out of the computer or keeping it somewhere where we cannot control access to it. We can go to hibernation and that's it. If we went to hibernation, then no fireware will not help anyone. Because again, we have nothing in memory, everything is encrypted. Yeah. But in fact, you said that fireware and live memory analysis, these are rare cases, but believe me, I have big experience working in the computer criminalistics. And indeed, there are many cases when I was removing memory through fireware, and for example, to me, so far I know of nothing full disk encryptors which would protect keys against direct search memory. And in fact, if you would implement that, that would be a very strong thing. You see, only hardware can do that. Some processors support that. I don't remember exactly what's their name, like A5, I don't know. They have a special module there which works on the processor level and it's hard to get to extract the key out of it. But I'd like to say that if the processor is different, then we can simply need to watch computer closely and often move to its hibernation. You don't want to take it away and install fireware, switch it off as soon as possible. So it's very simplified cold boot attack. Instead of fighting with our BIOS or carry with yourself liquid nitrogen, the abuser needs to get the malware into our computer. We need to make sure that the computer is less on, switched on. It's clear that you can protect the keys on the hardware level. It looks a bit strange to me because IS key 256-bit could be stored at the registry and no fireware will have it. The first way, which is quite obvious, and the second way, There are methods of non-hardware hiding keys, in particular hiding keys behind masks. In particular, yesterday, the report of amphitheater report, they were talking about this way, and it would be interesting if it would be somewhere else. Yes, we can also use the hardware encryption of hard disks, but with the software, yes, sure, we can complicate that. It will not fully remove the possibility. We can complicate it, but that requires very deep modification of the code, and I think that it will come to losing trust to this code. And then, like this, I have 10 lines with bash scripts. With anyone who understands something about that will be able to check. And otherwise, we'll have a patch with several thousand lines with a crypt set, and it will be more difficult to check, and possibly an implementation that can add some additional vulnerabilities there, simply because I have not enough qualification to realize that thing. If I find this encryption, which would allow me to get protected against these attacks, I will use that in this scheme. Okay, thank you for the answer.